Next slide, please. One of the earlier questions asked about what are you all looking for, and one of those is energy savings and reported benefits. So I'm going to present some of that data. It varies. The first thing to know about lighting, P&L, we analyzed roughly 4,000 different projects, mostly retrofits, and we found that by shifting from fluorescent and HID, without knowing anything about your project, you're probably going to get about 50% energy savings. And that's from, as I said, about 4,000 projects we analyzed. We also were able to analyze a smaller set of projects using controls. That's somewhat typical, mainly because fewer projects utilize lighting controls, and they've added somewhere between 5 and 25% savings on top of those savings of LED. Now, again, your space will vary, your mileage will vary, that type of thing, but that's a type of soft rule that you can use when you're analyzing your shift to this technology. Beyond 75% savings is possible, but it starts getting extremely harder. One reason is that buildings are not necessarily well daylighted, so it's harder to push lighting further and further into spaces. Also, we need to be in the spaces, so some level of occupancy sensors just can't save it because you're in there. And then finally, you're going to need some load. But it is still a significant amount of savings. And why it's important is that most buildings now require some type of lighting control. And as we've heard in the two previous presentations, you can use that control signal, primarily the occupancy sensor, and feed it into other types of technology. One example is plug loads. Lighting and HVAC are representing a sizable portion of your building's energy usage. In time, lighting has really come down partially because of the use of LEDs and other things. HVAC has had some savings as well, but not nearly as much as lighting has in the last few years. The one building load that is increasing more than anything else is what we call plug loads or miscellaneous electric loads. They're slightly different, but they are roughly the same type of thing. And that's an important thing to know, and that's why we started really focusing on that plug load environment. We analyzed about 7 to 10 different projects and reports, and the savings is somewhere in the neighborhood of 19 to 38%, with most of it coalescing in the mid 20% savings. Most energy codes, whether it's the national ones of IECC or Standard 90.1 or state specific, such as New York or California Title 24, all require some level of automatic receptacle controls in certain spaces, in certain building types. Why that matters? Well, if you're already going to be controlling your receptacles, how are you going to be doing it? And now through smarter technology and integration, we are able to do that really with remote receivers at the receptacle level, thereby reducing some of your costs in those retrofit applications or new construction applications. And that's where some of this integration starts tying in. Finally, we also analyzed a number of reports and projects related to HVAC integration using this occupancy-based control to set back either the temperature, fan, and other factions. That saves somewhere between 18 and possibly even 50%. That is a combination of modeled and measured results. I'm always a little cautious on modeled results. Those tend to be a little higher than practice. So I would tell you HVAC controls, you're probably in the mid 20 to 30% savings. But that is substantial, mainly because of the size of the actual overall load of what your HVAC represents. So saving that portion is still really worth considering. It's also worth noting Title 24, as well as some aspects of national codes, they are requiring some interaction with HVAC already. Often you're using that for direct ventilation control or other things, and it is beginning to grow this more integration through lighting controls. So there are savings potential as well as code reasons why you might want to consider integrating your systems. Next slide, please. So the Department of Energy is either directly or indirectly in 7 different projects that are actively in the field right now. They are all retrofits of integrating at least lighting with HVAC and most often lighting HVAC and plug loads. You can see from these different photos, they can be a myriad of different projects. The military it's a combination of both high bay and low bay. You can also do federal government or university facilities. It really doesn't matter the building type of the integration. However, I would tell you that savings will definitely vary both on your building type as well as your building design and your mechanical system. Some of the comments or questions asked about some of the non-exemplary elements. Sometimes we learn more from failure. I would tell you that the military installation, when they integrated their plug load, it went pretty well. However, they did have a setback in having to update the firmware. So that was a slight setback, but also they didn't realize all the savings they could. And they did recognize about a 38% energy savings, but not as much kWh savings as they would like. And I would tell you that when you are doing a plug load design, it's really important to have a champion on site. You need somebody who's actively encouraging which loads should be in that switched receptacle. Also, as an industry, we have really not done a great job of really indicating what is the switched receptacle. There is a little NEC designation, but you really have to get down there. They almost should be possibly painted a different color or something, some level of indication so that people are not negatively affected by plugging in something like a computer and then having to wait for a boot up overnight or other things. A lot of corporations do push updates overnight when we're not there, and that's the type of thing you don't want on a plug load. But you can do it. It just really requires an on-site champion to help remind people and really pay attention to what people are plugging in. HVAC integration can range. The military installation I'm referencing here, that had a really pretty almost seamless integration. It really went very easily. Other sites, the BACnet and lighting controls have had some BACnet limitations on the size of the objects, the number of objects, as well as verification. I would tell you that was probably one of the harder things to do with this technology, is that on paper it sounds like it makes sense, but because it's HVAC, it's a little harder to verify in practice that's actually happening. You need to let it run for a week or two just so you can see that data, mainly because of the thermal environment outside directly affects that your loads inside. So it's not like lighting where I walk away and I come back 10 minutes later and I know the light's off because there's no light. With HVAC, you really need to monitor the building a longer period of time to make sure the integration is successful. And you can also then make sequence changes as a result of that. But it is a slightly slower verification process, but well worth it. Next slide, please. These are just two sample plots from actual ongoing measurements, just really to kind of show you what the range of data that you can see. Over on the right here, this is just one of the projects we refer to as the county. This is actually the outpatient facility of it. You can see on the x-axis the dates and the y-axis the load. And you can see by the blue and the red, when the space is unoccupied, that load is dropping significantly. We found that majority of your savings are not occurring when you're in the space, does that make sense? But there's a significant amount of load that is just sitting there idle, off hours, weekends. That's a great thing to capture savings. Similarly, on the left, the fan data, we have gotten into an industry where we've programmed fans and other things based on building occupancy. But space occupancy is not the same as building occupancy. And this is a university, and their building occupancy on schedule is something like 7 a.m. to 9 p.m. But many of the rooms are not used that way. And as a result, you can see by the high significant peaks that once that space was unoccupied, that fan was able to drop out and thereby saving additional energy.